Hello and welcome to Data Engineering with Subhadeep. In today's tutorial, we are going to dive deep into advanced SQL analytics, focusing specifically on time series modeling directly within your database. We will cover three powerful techniques. First, we will use moving averages to smooth out data and identify trends. Next, we will explore the lag and lead functions to calculate key performance indicators. Then, we will build a cohort analysis to track user retention. Finally, we will put it all together to detect anomalies in our data. The core concept behind all these techniques is SQL window functions. Unlike aggregate functions which collapse rows, window functions perform a calculation for each row based on a related set of rows defined by the over clause. This allows us to compute things like running totals and moving averages. Let's start with moving averages. They help smooth out short-term fluctuations to highlight longer-term trends. Imagine we want to calculate a 3-day moving average for sales. We use the AVG function over a window defined by the current row and the two preceding rows. As you can see in the table, the average for January 3rd is the average of sales from January 1st, 2nd, and 3rd. Next, let's look at lag and lead. These are incredibly useful for comparing values between rows. A classic use case is calculating month-over-month growth. The lag function allows us to pull a value from a previous row. Here, we fetch the sales from the previous month. Once we have both current and previous month sales in the same row, calculating the growth percentage is simple arithmetic. Now for a more advanced topic, cohort retention analysis. A cohort is simply a group of users who share a common starting point, like their sign-up month. By tracking how many users from each cohort return over time, we can measure product stickiness and understand user engagement much better than with simple daily active user counts. Building a cohort chart in SQL is a two-step process. First, for each user activity, we need to identify the user's cohort, which is their registration month. Then, we calculate the user age at the time of the activity, which is the number of months that have passed since they first signed up. In the second step, we aggregate this data, we group by the cohort month, and then use conditional aggregation with case statements to count the number of unique users who were active in each subsequent month. This pivots the data and creates the classic retention matrix, showing us how each cohort performs over time. Finally, let's combine these concepts for a powerful use case, anomaly detection. We can identify unusual events by finding data points that deviate significantly from the norm. A common method is to flag anything that is more than 3 standard deviations away from a moving average. This SQL query first calculates the 30-day moving average and standard deviation for website traffic, and then simply filters for the days where the traffic exceeds this threshold. So let's recap. We have learned how to use moving averages to see trends, how to use lag and lead for period-over-period calculations, and how to perform a full cohort retention analysis. The key takeaway is that modern SQL is an incredibly powerful tool that allows you to perform sophisticated analysis directly within your data warehouse. Thank you for watching this tutorial. I hope you found these advanced SQL techniques useful. If you enjoyed this video, please hit the like button, share it with your colleagues, and subscribe to Data Engineering with Subhadeep for more tutorials. See you in the next one.